the sunset that isn't finished yet. If you stood on the surface of Venus and watched the sun finally slip below the horizon, you would have to wait over 4,000 Earth days just to see it rise again. But by the time it actually did, the planet itself would have already finished 2 entire trips around the star it was watching. The air in the room right now probably feels a little heavier than it did an hour ago, settling into the corners where the light doesn't quite get. There is a specific kind of quiet that only happens when you stop trying to measure things. It makes you wonder what it feels like to be trapped inside a clock that is ticking backward, watching the hands move the wrong way while the room around you stays perfectly still. It is the exact frequency we try to tune into here at Sleepy Science Channel, just letting the mechanics of the dark sit with us for a while. I sometimes wonder if anyone else has ever looked up at the night sky and tried to guess which of those wandering lights is currently spinning the wrong way, and if they ever left a thought about it in the quiet space below. We are so used to the idea of a day being a fraction of a year, a small slice of a much larger pie, that the alternative feels like a mistake in the math, a glitch in the way we expect the universe to keep time. On Venus, the thing we call a day is not shorter than the thing we call a year, which is longer, and if you set a clock for the spin and a calendar for the loop around the sun, you just have to watch them stop matching each other. The mismatch doesn't fix, it just sits there, correct, unbothered, quietly wrong in every way a normal planet would find embarrassing. You have to let go of the earthbound habit of expecting the calendar to keep up with the clock, because here, the calendar finishes its lap, checks its watch, and realizes the clock is still only halfway through its first tick. It is a profound kind of desynchronization, a mechanical stubbornness that refuses to be smoothed out by time, leaving you with a day that outlasts the very year it is supposed to be a part of. No telescope ever saw this happen, because the clouds made sure of that, wrapping the planet in a thick, opaque blanket that refused to let any visible light through to show us the surface moving. What caught it instead was a radio dish in a California desert, bouncing a signal off a surface no human eye had touched, listening to the echo come back slightly off. That wrongness had a shape, a specific distortion in the returning radar waves that told the people listening that the ground below the clouds was not staying still, but moving at a pace so slow it barely registered against the background noise of the solar system. The shape had a number, a precise measurement of the Doppler shift that translated into a rotation period of roughly 243 Earth days, a number that didn't match anything anyone expected, and for a while nobody quite believed it. There is a resonance in the orbital mechanics, a specific gravitational hum that keeps the planet locked in a strange dance with Earth when they are closest. But the exact nature of that lock is something we will just leave sitting in the dark for now. The instrument caught the ghost of a movement, a slow, creeping crawl of rock and metal that defied every assumption we had about how a planet of its size was supposed to behave in the dark. Ask which direction the sun rises here, and the answer breaks something small in the back of your mind, because east and west trade places, not symbolically, but physically, mechanically, for real. The whole planet goes the opposite way it is supposed to, turning on its axis from east to west, while almost every other world in the solar system spins the other way, and nobody agreed on that except the planet itself, which never asked permission in the first place. We look for a reason, a clean mechanical excuse for the backward spin. But the universe rarely hands us a clean excuse, it just hands us the aftermath. Something did this to the planet, and nobody agrees on what, leaving us with a handful of theories that sit side by side in the literature, none of them entirely satisfied with the others. Maybe it was the thick atmosphere, dragging against the rock for billions of years, a friction so vast and so slow that it eventually just dragged the spin to a halt and pushed it backward. Maybe it was old tides from a sun that never let go, pulling at the crust until the momentum reversed. Maybe it was a collision so far back in the deep time of the solar system that it left no fingerprints, only consequences, a massive impact that flipped the axis and sent the world spinning in the wrong direction. 3 explanations, none confirmed, each one changing the whole story depending on which you choose to believe on a given afternoon, leaving the backward spin as just another quiet mystery sitting under the clouds. Here is the part that ruins the tidy version of the fact. The piece of the puzzle that makes the math is just broken if you only look at the first 2 numbers. The spin is 243 Earth days, and the year is 225 Earth days, meaning the day is longer than the year. But because the spin runs backward while the planet also drifts forward around the sun, the actual stretch from sunrise to sunrise is shorter than both. It takes only about 116 Earth days for the sun to go down and come back up again, a solar day that is barely half the length of the spin and slightly more than half the length of the year. The true day hides inside the slower one, uncounted, doing the opposite of what the headline implies, because the backward rotation means the sun catches up to the horizon much faster than it would if the planet were spinning forward. So the simplest version of the fact was never quite true, a headline that sounds profound but falls apart the moment you do the actual math, revealing a hidden solar day that is shorter than the year it supposedly outlasts. It is a trick of perspective, a mechanical illusion created by the intersection of a backward spin and a forward orbit, leaving you with a day that is simultaneously longer and shorter than the year, depending on which clock you decide to trust. Stand on this surface, if you could, and the air above you would be lapping the planet every 4 days while the ground beneath you takes months to turn once. A staggering disconnect between the sky and the dirt. The atmosphere is just thick, a crushing blanket of carbon dioxide that moves with a frantic, super-rotating energy, circling the globe at speeds that would tear a human apart, while the surface below barely creeps along at a fraction of a mile per hour. The sky and the soil are not really moving together. They just happen to share an address, locked in the same gravitational well, but operating on completely different schedules. One is patient, grinding out its rotation over hundreds of days, while the other is frantic, racing around the planet in a matter of hours, driven by the intense heat of the sun absorbed by the clouds. Neither one seems to notice the other. The wind just moves, howling through the upper atmosphere in a perpetual high-speed jet stream that has nothing to do with the slow, agonizing turn of the ground below. It is a world divided against itself, a place where the weather and the geology are completely out of sync, sharing a planet but living in entirely different time zones. Pick one particle of dust resting on that ground right now, a single grain of basalt or sulfur sitting in the crushing pressure of the lower atmosphere, and consider the sheer weight of the time it has to endure. In the time it takes to notice one sunrise arrive and finish leaving, almost nothing else about it will change, because the sunrise itself takes 116 Earth days to complete its arc across the sky. It will not remember the wind above it, the frantic 4-day super rotation that howls through the clouds far above its head, or the argument about why the spin is slow, the endless debates in quiet offices about tides and collisions and atmospheric drag. It will just stay there, having outlasted very little, waiting for a light that is already, technically, running late, sitting in a darkness that feels permanent because it stretches across so many of our own years. The dust doesn't know about the clocks or the mismatch or the backward spin. It just exists in the quiet, enduring the long, slow turn of a world that refuses to keep time the way we do. The sun goes down, the shadows stretch, the ground turns, very slowly. The clocks disagree, they always will. The year ends, the day continues, the dust sits, waiting for the light to return. Two clocks that refuse to agree. The clocks are already running, both of them. They have been running for a very long time, and they are not running at the same speed, and neither one has shown any sign of waiting for the other. One clock measures the spin, the body turning on its axis, the slow grind of rock completing a single revolution against the backdrop of distant stars. On this world, that clock ticks once every 243 Earth days, a full rotation, one turn, the kind of movement we're used to finishing before breakfast, stretched out here into something that takes longer than most human pregnancies. The other clock measures the orbit, the long loop around the sun, the curved path through space that defines what we call a year. That clock ticks once every 225 Earth days. One lap, one full journey from a point in space back to that same point again. The problem is not that the clocks are wrong. The problem is that they are both right, at the same time, in a way that should not be possible if you grew up on a world where the day is always a fraction of the year, where 24 hours fits neatly inside 365, where the small unit divides evenly into the large one and nobody has to think about it. Here, the small unit is bigger than the large one. The day outlasts the year. And this is not a rounding error, not a trick of perspective, not a footnote. It is the operating condition. It has been the operating condition for longer than complex life has existed on Earth. Think about what that means for a calendar. On Earth you can mark a birthday and know the sun will rise and set roughly 365 times before it comes again. The day is the grain of sand and the year is the hourglass. The grain falls and falls and falls, and eventually the glass is empty and you start again. On Venus, the hourglass empties before a single grain has finished falling. The year completes itself. The orbit closes its loop. The planet returns to the same position relative to the sun. And the spin, the rotation, the day, is still working on its first turn. It is not finished. It is not close to finished. It will need roughly 18 more Earth days of grinding before it completes the revolution it started before the year even began. This is not a failure of design. There is no design to fail. This is just what happens when angular momentum and orbital mechanics arrive at numbers that do not care about human intuition. A year finishes, the day does not. Then a new year begins, and the day still hasn't finished. And somewhere in the middle of that second year, The day finally closes, and by then the calendar has already moved on to something else entirely. There is a number that comes out of this. 243 divided by 225. A ratio. And if you look at that ratio long enough, you notice it is close to a fraction. 13 to 12. The planet rotates 13 times for every 12 orbits it completes, roughly, and the nearness of that fraction has kept people arguing for decades about whether it is a coincidence or a lock, whether something in the gravitational machinery of the inner solar system is quietly enforcing a relationship that looks almost intentional, but probably isn't. The ratio sits there whether you believe in intention or not. The clocks keep running whether you find a pattern in them or not. On Earth, we build our lives around the agreement between these two clocks. We expect them to cooperate. Seasons arrive in rhythm with daylight. Planting and harvest depend on the assumption that the year contains many days, that the cycle of light is faster than the cycle of warmth, that the small hand moves faster than the big hand. This assumption is so deep in our thinking that we barely register it as an assumption. It feels like a law. On Venus, it is not a law. It is not even a suggestion. The two clocks simply disagree, and they have disagreed for billions of years, and the disagreement has not produced any crisis, because there is nothing on the surface that needs the clocks to agree. No biology depends on the rhythm. No civilization schedules its meals around the sunrise. The clocks disagree in a vacuum of consequence, which is perhaps the only reason the disagreement can persist so calmly. If you tried to live there, if you tried to impose a schedule on the surface, you would go mad trying to reconcile the two. You would set your alarm for sunrise and find that your annual report was due 3 sunrises ago. You would celebrate a new year and realize the day had not yet changed. The clocks would pull your attention in 2 directions that never converge, and eventually you would stop looking at either one. The planet does not look at either one. It just turns and it orbits, and the turning and the orbiting proceed at their own rates, indifferent to the fact that those rates produce a relationship no other world in the solar system shares in quite this way. Mercury has its own strange ratio, its own argument between spin and orbit, but even Mercury's clocks eventually synchronize into a pattern that repeats cleanly. 3 rotations for every 2 orbits. A lock. A handshake. Venus does not shake hands with anything. The near 13 to 12 ratio is close enough to suggest a lock but loose enough to deny one. It sits in the space between order and accident, and it has sat there long enough that the distinction may no longer matter. The clocks run. The day exceeds the year. The year does not wait. And somewhere in the mathematics of it, in the quiet arithmetic that governs how bodies move through space, there is a sentence that is still being written, one that will not end until something changes the spin or the orbit or both, and nothing has shown any interest in doing either of those things for a very, very long time, and nothing is likely to start soon, because the forces that could change it are too small, and the time required is too long, and the universe has other things to be doing while these 2 clocks continue their slow, polite, permanent disagreement, each one correct, each one indifferent, each one measuring a truth the other does not acknowledge, both of them ticking in a silence so complete that calling it silence almost makes it sound like something was supposed to be there in the first place. The clocks are not broken. They are simply not listening to each other. Which way is backward? You think you know which way a planet turns because you have only ever stood on one that turns the same way as almost everything else, and the assumption has never had a reason to surface until now. East to west, or west to east. It sounds like a trivial distinction, the kind of thing you file away in a textbook and forget by the next page. But stand on a surface and watch the sun come up over the wrong horizon, and something in your orientation breaks. Not dramatically, quietly, the way a compass needle swings past north and keeps going. Most of the planets in the solar system spin counterclockwise when viewed from above the sun's north pole. Earth does, Mars does, Jupiter, Saturn, Neptune. They all turn the same way, as if they were all poured from the same spinning disk of gas and dust, which they were 4.5 billion years ago, when the solar nebula collapsed and flattened and started rotating in a direction that everything born from it inherited. Venus did not inherit it, or it did, and then something took it away. The planet turns clockwise. Retrograde, the word is, a term that carries a faint sense of apology, as if the planet is moving in reverse through its own history, as if it is backing out of a room it entered by mistake. The axis tilts at 177 degrees, which is another way of saying it is almost perfectly upside down, tilted so far past vertical that calling it a tilt barely captures the violence of the geometry. Imagine holding a spinning top and slowly pushing it past upright, past sideways, all the way over until it is spinning on its head. That is what this looks like from the outside. The top is still spinning. The direction of the spin, relative to the room, has reversed. Now imagine the top is a world. Imagine the room is the solar system. And imagine no one was in the room to see it happen. The bodily experience of this, if you could somehow stand on the surface and survive the 460 degrees and the 92 atmospheres of pressure, would be a kind of persistent wrongness in the sky. The sun would rise in the west. It would cross the sky in a direction that every instinct you carry tells you is backward. It would set in the east, and your body, which evolved on a world where light comes from the left and moves right, where shadows swing clockwise through the afternoon, would never fully adjust. You would feel, in some deep vestibular way, that the planet was lying to you. But the planet is not lying. It is simply doing what it does. The label of backward belongs to us, not to it. There is no forward in space. There is no correct direction to spin. There is only the direction you ended up spinning, and the direction everything around you happens to be spinning, and the gap between those two things, which we fill with words like retrograde, because we need a way to talk about the discomfort of being the one going the other way. There is a loneliness in that word, retrograde. It implies a consensus that someone has stepped outside of. It implies a normal that this world is failing to meet. And while the universe does not care about normal, the word carries a faint judgment, a whisper of something gone wrong, even though nothing has gone wrong at all. Something just went differently, a long time ago, in conditions no one can reconstruct. The spatial reality is stranger than the word suggests. If you looked down at the solar system from above, you would see almost everything turning left. The sun turns left. The planets orbit left. Most of the moons orbit left. The whole system moves like a single vast mechanism, all its gears meshed in the same direction. And then there is this one, turning right, quietly, under its clouds, at a speed so slow you could watch it for an hour and not be sure it had moved at all. The isolation of that is hard to name. It is not defiance, because defiance requires intention, and a planet does not intend anything. It is not rebellion, because rebellion requires a cause, and whatever caused this is buried so deep in time that it may not even have left evidence. It is just a direction, a solitary, persistent, mechanical fact operating in the opposite sense of everything around it, and doing so without drama, without apology, without any visible awareness that it is the only one. Some of the smaller bodies in the solar system also turn backward. Pluto does, a few moons do. But those are small, and their backwardness is easier to explain. Captures, collisions, the chaotic aftermath of a crowded early solar system, where things were constantly hitting each other and flipping over. Small things are easy to flip. Venus is not small. Venus is nearly the size of Earth. Its mass is enormous. The energy required to reverse the spin of a world that large is almost beyond calculation. It would take an impact of staggering proportions, or a process operating over billions of years, with a patience that makes geological time look hurried. Either way, something spent an extraordinary amount of effort to make this planet turn the wrong way, and then left without explaining why. The thread of this thought, which way is backward, and who decided, and what it means to be the one going the other direction, does not resolve. It runs all the way down to the core of the planet, through the iron and the rock and the slow, thick mantle, and comes out the other side still pulling, still asking a question that has no answer, because the question assumes a framework the universe does not recognize. There is no forward, there is no backward, there is only spin, an orbit, and the long, unbothered persistence of a body that turns the way it turns, because that is the way it ended up turning, and it has never once considered the possibility that it was supposed to turn any other way, the instrument that caught it without seeing it. In the spring of 1961, in a stretch of desert east of Los Angeles where the air is dry enough to let radio waves pass through without distortion, a dish that had been built to track things much closer to home was pointed at a light in the evening sky that nobody had ever been able to look at directly, not because it was too far away, but because it was too thoroughly hidden, wrapped in a permanent shroud of sulfuric acid clouds that reflected sunlight so completely that the planet appeared as nothing more than a bright, featureless pearl, beautiful and absolutely silent about what was happening underneath. The dish was at Goldstone. It was part of the Deep Space Network, a system designed to talk to spacecraft, to send commands and receive whispers from probes that were, at that point, barely beginning to leave Earth's neighborhood. But in the early 60s, before very many spacecraft existed to talk to, the dishes were sometimes turned toward planets instead, not to communicate but to listen, to send a pulse of radio energy outward and wait for it to come back, changed. This is how radar works. You shout into the dark and you listen for the echo, and the echo tells you something about the wall it bounced off of, how far away, how hard, how rough. And if the wall is moving, if it is turning toward you or away from you, the echo comes back at a slightly different pitch than the one you sent. The Doppler effect. The same thing that makes a siren sound higher as it approaches and lower as it recedes. Radio waves do the same thing, though the shift is far too small for any human ear to detect. It has to be measured in fractions of a hertz, in mathematical differences so slight they require equipment that did not exist until a few years before this moment. The team at Goldstone sent their signal toward Venus. It travelled for several minutes, crossing the shrinking gap between the two planets as they approached each other in their orbits. It hit the cloud layer, passed through it. Radio waves do not care about sulfuric acid. Struck the surface and came back. The echo arrived slightly wrong. Not wrong in the way that means broken. Wrong in the way that means new information. The frequency of the returning signal had shifted. The surface of Venus was moving. It was rotating. And the direction and speed of that rotation, encoded in the tiny compression and stretching of the radio waves, produced a number that no one had predicted and that several people initially refused to accept. 243 days, plus or minus a margin that got smaller with each subsequent measurement over the following years. A single rotation taking longer than the planet's entire trip around the Sun. And the shift in the echo confirmed not just the speed but the direction. Retrograde. Backward. The surface was turning the wrong way, and the radio waves had caught it doing so without ever seeing it. Think about what was happening in the signal itself during those minutes of travel. A pulse of electromagnetic energy, organized into a precise frequency by human engineering, leaves a metal dish in a desert, crosses 100 million kilometers of vacuum, enters an atmosphere thicker than any we had encountered at that point, passes through clouds that would dissolve steel, strikes a surface hot enough to melt lead, and bounces back with a fingerprint on it. A tiny, measurable distortion that carries the signature of the ground's movement. The entire process depends on the fact that the universe is consistent, that a radio wave will behave the same way in the atmosphere of Venus as it does in the desert of California, that the Doppler effect does not take a day off, that the mathematics connecting frequency shift to velocity will hold true across a distance that the human mind cannot honestly picture. And it did hold. The number came back clean. The signal had done exactly what it was supposed to do, which was to return with the truth written on it, in a language that only instruments could read. No one saw the surface. No one has seen the surface of Venus with their own eyes from orbit, not in visible light, not through those clouds. Everything we know about the ground, the vast plains of basalt, the shield volcanoes, the strange tessellated highlands, comes from radar, from signals sent and received, from echoes that arrived carrying shapes instead of sounds. The Magellan spacecraft would later map nearly the entire surface this way, in the early 1990s, building a picture of the planet one radar stripe at a time, assembling a world from the time delays and frequency shifts of reflected microwaves. But the first hint, the first crack in the clouds, came from a dish in the desert that was not even looking for what it found. The signal went out. It came back. It was different. The difference meant something. The something was slow, and backward, and real. A wind that moves faster than the ground. It sits on. You're inside the atmosphere now, and it is moving, and the ground below you is not. And the difference between those two facts is the entire story of a world that has torn itself into two separate schedules operating in the same space. The atmosphere of Venus is not like ours. Ours is thin, transparent, and relatively obedient. It moves when the sun heats it, when pressure gradients push it, when mountains deflect it. But it mostly stays in conversation with the surface, responding to the ground's temperature, the ground's shape, the ground's slow rotation. Our atmosphere and our surface negotiate. They are in a relationship, sometimes tense, mostly functional, each one aware of the other's movements. On Venus, the atmosphere has stopped negotiating. The term is atmospheric superrotation, and it means exactly what it sounds like. The air is rotating faster than the planet beneath it, so much faster that the comparison barely registers as a comparison and starts to look more like two entirely separate systems that happen to occupy the same gravitational address. The atmosphere completes a full circuit of the planet roughly every 4 Earth days. The surface takes 243. That is not a difference of degree, that is a difference of category. Imagine standing still in a hallway while the air in the hallway decides to sprint. Not a breeze, not a gust. A sustained, permanent global-scale wind that moves at roughly 100 meters per second at the cloud tops, circling the entire planet in less than 100 hours, driven by energy that we can identify but cannot fully explain. The energy comes from the sun. That much is clear. The thick clouds absorb solar radiation, the atmosphere heats unevenly, and the resulting pressure differences drive winds. On Earth, this same process creates weather, storms, jet streams, trade winds, all of it ultimately tied to the rotation of the planet below, which organizes the air into patterns through the Coriolis effect and keeps the whole system more or less coherent. On Venus, the Coriolis effect is almost absent, because the surface rotation is so slow that it barely exerts any organizing influence on the air above it. The atmosphere is free to do what it wants, and what it wants is to go. Fast, in one direction, all the time. The result is a super-rotating shell of gas that wraps the planet in a perpetual eastward wind, a river of air that circles the globe without stopping, without seasons, without the daily rhythm of heating and cooling that structures weather on faster spinning worlds. The bodily experience of this, if you could survive the surface conditions long enough to feel it, would be a kind of permanent horizontal pressure, not from one direction but from above, from the sky itself, which is moving with a violence that the ground does not share. You would feel the weight of the atmosphere, 92 times the pressure of Earth's air at sea level, a crushing density that would make every breath feel like drinking, and within that weight you would feel the movement, a ceaseless lateral pull that never relents because the wind never stops, never reverses, never calms down to let the surface catch up. The ground does not try to catch up. The ground turns at its own pace, a pace so slow that a person standing on it could watch the wind above and feel, in some pre-rational part of the body, that they were perfectly still and the sky was leaving without them. The sensation would not be one of wind in the face. The lower atmosphere moves more slowly than the upper layers, but of a world divided, a place where the floor and the ceiling have agreed to disagree about what speed means, what time means, what it means to be in motion at all. The pulse of this system expands outward from the surface, where the air is dense and sluggish, up through the middle atmosphere, where the wind accelerates, and into the cloud tops, where it reaches its peak velocity, and then it contracts again, thinning into the upper atmosphere where the air is too sparse to carry the momentum, and the wind gradually loses itself in the near vacuum above. Expansion and contraction, density and speed, the ground's patience and the sky's urgency, all of it cycling in a pattern that repeats every 4 days without variation, without memory, without any indication that it will ever change. We do not fully understand what sustains it. We know the sun provides the energy, and we know the slow rotation removes the organizing force that would normally structure the wind into smaller, more manageable systems. But the mechanism that converts solar heating into a single, coherent, global-scale super-rotation, a wind that moves 60 times faster than the ground and never breaks down, never fragments, never slows, remains one of the unsolved problems of planetary science, a question that sits inside the atmosphere, like a stone in a river, shaping the flow around it without being moved by it. The wind goes, the ground stays. The gap between them is not a failure, it is a condition, and it has been a condition for long enough that it has stopped being strange and has simply become the way things are. A permanent disagreement between the sky and the floor of a world that learned, at some point in its deep and unrecorded past, to move in two directions at once and never saw a reason to stop. The day that isn't the day you think. The headline has already been written, and it is already slightly wrong, and the wrongness is not dramatic, but it is persistent. The kind of error that does not collapse the building, but makes the door stick every time you try to open it. The day is longer than the year. That is the headline. It is simple. It is memorable. It fits on a card, in a list, in the kind of fact that gets repeated at dinners and in classrooms and in the quiet hours when someone is scrolling through things they half remember reading. But the day that is longer than the year is not the day you experience if you stand on the surface and watch the sun. The day that is longer than the year is the sidereal day, the time it takes for the planet to complete one full rotation relative to the distant stars. 243 Earth days. That is a real number. It is accurate. It is measured and confirmed and agreed upon by every instrument that has ever looked at this problem. But it is not the day you would see. The day you would see, the solar day, the stretch from one sunrise to the next, is shorter, much shorter. 116 Earth days, roughly. Less than half the sidereal day. Less than half the year. A number that hides inside the larger numbers like a smaller animal inside the rib cage of a larger one, alive and moving and entirely ignored by the bones around it. The reason for this is the backward spin. Because the planet rotates in the opposite direction from its orbit, the sun does not have to wait for the full rotation to catch up to the horizon. It catches up sooner. The retrograde motion means the sun and the rotation are moving toward each other rather than in the same direction, and so they meet more frequently than you would expect from either number alone. If the planet spun forward, like Earth, the solar day would be slightly longer than the sidereal day, because the rotation would have to go a little extra to make up for the ground the orbit covered during the spin. On Earth, this adds about 4 minutes. On a forward-spinning Venus it would add considerably more because the orbit covers a lot of ground relative to the slow spin. But Venus does not spin forward. It spins backward. And so the math inverts. The solar day becomes shorter than the sidereal day, not longer. The sun arrives early. It arrives so early, in fact, that it arrives before either the spin or the orbit has completed a single cycle, which means the solar day, the thing you would actually experience, the thing that would govern your waking and sleeping if you could somehow wake and sleep on a world with a surface temperature of 462 degrees, is shorter than both the numbers that supposedly define it. This is where I become uncertain. Not about the math. The math is clean. The equations that produce 116 days from 243 and 225 are straightforward and have been verified many times. I am uncertain about what it means to say that the day is longer than the year, when the day that a living thing would actually observe is shorter than the year. Which day is the day? The one the stars see, or the one the sun sees? The stars see 243 days. The sun sees 116. A clock on the surface, if it could survive the surface, would see 116. A calendar tracking the orbit would see 225. 3 numbers, 3 different truths, all of them correct, none of them sufficient on its own, each one requiring the others to be understood, and none of them willing to yield to a single clean statement. The day is longer than the year, except when it isn't, except when it's shorter, except when it depends on what you mean by day, which depends on what you are standing on, which depends on whether you can stand on it at all, which depends on questions that have nothing to do with time and everything to do with heat and pressure and the particular chemistry of an atmosphere that was never designed to let anyone stand on anything in the first place. The headline persists anyway. The day is longer than the year. It is repeated because it is striking, because it disrupts a comfortable assumption, because it makes people pause and reconsider the relationship between small units and large ones. And it is not wrong exactly. It is just incomplete. It tells one truth and leaves another sitting quietly in the margin, unacknowledged, doing its own math, producing its own number, waiting for someone to notice that the simplest version of a fact is almost never the whole version. The solar day sits there, 116 days, shorter than the year, shorter than the spin, a hidden day inside a longer one, uncounted by the headline, unbothered by the attention the headline receives, just doing what days do, marking the passage of light, even on a world where the light takes so long to cross the sky that calling it a day feels like using a word meant for smaller things. The numbers are correct. The headline is incomplete. And the gap between those two statements is wide enough to hold a truth that nobody has found a clean way to say yet. What slowed it down? Far from here, in a time before there were people to name things, something happened to this planet that changed the way it turns, and we do not know what it was, and we may never know. And the not knowing is not a failure of effort, but a feature of a universe that does not keep receipts for the things it does to itself. There are 3 explanations. They sit in the literature like 3 chairs around a table, each one occupied by a different group of people who have spent years building the case for why their chair is the right one, and none of them has managed to convince the others to stand up and move. The first explanation is atmospheric. Venus has an atmosphere so thick and so dense that it exerts a measurable physical drag on the surface below it. This is not a gentle effect. The atmospheric pressure at the surface is roughly 92 times what it is on Earth at sea level. The air is not air in any sense we would recognize. It is a supercritical fluid, a state of matter that blurs the line between gas and liquid, and it moves with enough force and enough mass that, over billions of years, it could act like a brake on the planet's rotation. The mechanism is called atmospheric thermal tide. The sun heats one side of the atmosphere more than the other, creating pressure bulges that are slightly offset from the subsolar point. These bulges exert a gravitational and pressure torque on the solid planet below. On Earth, this effect is negligible. On Venus, with its massive atmosphere and its slow rotation, the torque is significant, large enough, some models suggest, to have gradually slowed the original spin and eventually pushed it backward. The atmosphere dragged the planet to a stop and then kept dragging, and the planet, lacking the angular momentum to resist, simply went with it. The second explanation is gravitational. The Sun is very close to Venus, much closer than it is to Earth. At that distance, tidal forces, the differential pull of the Sun's gravity on the near side versus the far side of the planet, are strong enough to deform the planet's interior, creating a tidal bulge in the solid body itself, not just in any oceans, because Venus has no oceans. This bulge, dragged slightly ahead or behind by the planet's rotation, creates a torque that can slow the spin over time. The same mechanism is what locked the Moon into showing us the same face forever, and what is slowly, imperceptibly lengthening Earth's day by a few milliseconds per century. On Venus, operating over billions of years, solar tides could have braked the original rotation down to near zero, and then, in combination with atmospheric effects or other perturbations, nudged it into the backward direction it occupies now. The third explanation is catastrophic. Something hit Venus. Something very large, very early, and very hard. In the first few 100 million years of the solar system, the inner planets were bombarded by debris left over from their own formation. Planetesimals, protoplanets, chunks of rock and iron the size of cities or continents, moving at speeds that turned every impact into an event of almost incomprehensible energy. A collision of the right size at the right angle, on the right part of the planet, could have reversed the spin entirely. The same kind of impact is widely believed to have created Earth's moon, and to have tilted Uranus onto its side. If it can knock a planet sideways, it can knock one backward. The problem with this explanation is that it leaves no evidence. The surface of Venus has been resurfaced by volcanic activity, probably multiple times, erasing the craters that might have recorded the impacts of its early history. There are no fingerprints, only consequences. Each of these explanations changes the story of Venus in a different way. If it was the atmosphere, then the backward spin is a slow, patient process, a grinding negotiation between gas and rock that took billions of years to reach its current state. If it was tides, then the backward spin is a gravitational inevitability, the predictable outcome of a planet living too close to its star. If it was an impact, then the backward spin is an accident, a single violent moment in a chaotic early solar system that happened to hit this particular world at this particular angle and changed everything without meaning to. The truth may be some combination of all three. The truth may be none of them. The truth may involve processes we have not yet thought to look for, operating on timescales we have not yet learned to measure, in conditions we cannot reproduce in any model we currently possess. The spatial arrangement of the inner solar system, the distances between the planets, the closeness of Venus to the Sun, the thickness of its atmosphere, the composition of its interior, all of these things are relevant. They are the conditions under which the spin was shaped, the walls of the room in which the clock was wound. But the room is dark, and the clock is very old, and the person who wound it, if there was a person, left a long time ago without leaving a note. We are left with the 3 chairs and the 3 explanations, and the quiet acknowledgement that the universe is not obligated to make its history, legible to the species that arrives 4 billion years late and starts asking questions. The spin is slow, the direction is backward, the cause is gone. What remains is the motion itself, turning, still. 1 grain, 1 sunrise. There is a particle of dust on the surface right now, and it has been there for longer than you have been alive, and it will be there when you are not alive anymore, and during the entire span of your existence and non-existence it will have moved almost nowhere, because the ground it rests on is turning at a speed so close to stillness that calling it movement is an act of generosity toward the word. The particle does not know about the rotation. It does not know about the orbit. It does not know that the year has already finished twice since it settled into the crack in the basalt where it currently sits, or that the sun has risen and set in the wrong direction exactly once during that time, or that the wind above it has circled the planet more than 140 times at speeds that would strip the flesh from a body if a body could exist in this place. It just sits. The temperature around it is 462 degrees Celsius, a heat that does not fluctuate the way heat does on Earth, that does not cool at night or warm in the afternoon, because the atmosphere is so thick and so efficient at distributing energy that the surface temperature is nearly the same everywhere, at all times, in all seasons, a constant that does not acknowledge the passage of the sun above it, because the sun above it barely registers through the clouds as anything more than a vague brightening, a shift from dark grey to slightly less dark grey, that takes weeks to complete and weeks to reverse. The pressure around it is 92 bars, a weight that presses in from every direction, with a force equivalent to being nearly a kilometre underwater on Earth. And this pressure does not fluctuate either, does not rise and fall with weather systems the way pressure does in thinner atmospheres, because the weather systems on Venus operate in the upper atmosphere, far above the surface, and the dense gas at ground level simply sits, compressed, motionless, a fluid so heavy it barely qualifies as air. In this environment, the particle of dust is not eroding. It is not being carried by wind, because the wind at the surface, despite the super-rotation above, moves at barely a metre per second, a gentle drift that is insufficient to lift a grain of this size. It is not being dissolved by rain, because there is no rain at the surface. The sulfuric acid that condenses in the upper clouds evaporates long before it reaches the ground, leaving the lower atmosphere dry and still and silent. It is not being buried by new material, because the volcanic activity that once reshaped the surface has been quiet for a long time, perhaps millions of years, leaving the landscape in a state of suspended animation that makes geological time on Earth look like a series of emergencies by comparison. The particle will sit through the next sunrise, which will arrive in its own time, which will take 116 Earth days to complete its arc, which will not look like a sunrise in any way that would comfort someone who has only ever seen the sun come up over the ocean, or the hills, or the rooftops of a city waking up to its alarm clocks and its schedules and its expectations about how long a morning should last. This sunrise will last for weeks. The light will not break suddenly over a horizon, because there is no clear horizon. The atmosphere bends and diffuses the light so thoroughly that the transition from dark to less dark is a gradient, not an event, a slow brightening that begins without announcement and ends without ceremony, a sunrise that does not know it is a sunrise because it has no sharp edge, No moment you could point to and say, there, that is when it started. The particle will not register this. It has no apparatus for registering. It is a grain of mineral, probably pyroxene or feldspar, born from a volcanic eruption that happened before humans had language, settled into a depression in the rock by gravity and the faintest breath of surface wind, and left there by the absence of any force strong enough to move it. It will sit through the next sunset too, which will be the same gradient in reverse, a slow dimming that takes weeks to complete, and after the sunset there will be darkness, not the darkness of a night on Earth that is punctuated by stars and moonlight and the distant glow of cities, but a darkness that is total and permanent and warm, a darkness that does not feel like the absence of anything, but simply like the default state, the condition the surface returns to and stays in for months at a time, patient and complete and uninterested in the light that will eventually, slowly, inevitably, begin to return. The thread of this thought, one grain, one sunrise, one uncounted moment in a timeline that does not care about counting, runs all the way to the end of the planet's current state, which is to say it runs nowhere, because the end is not visible, because there is no reason to expect the spin to change, or the orbit to shift, or the atmosphere to thin, or the surface to stir, because everything about this world is arranged for persistence, for the long, slow continuation of conditions that have already lasted longer than the species that noticed them. The particle sits, the sun moves, the ground turns, very slowly. The clocks disagree and neither one is wrong, and neither one will ever agree, and the particle does not need them to, because it is not keeping time. It is simply existing in a place where time has been stretched so thin that it barely qualifies as time anymore. A place where a single sunrise is a season, a single rotation is a lifetime, and a single grain of dust can outlast everything we have ever built, everything we have ever said, everything we have ever believed about how fast the world is supposed to turn. The weight of the air. You are falling through it. Not quickly. The air is too thick for that. You are sinking. The boundary between gas and liquid has stopped meaning anything. Down here, at the bottom of the atmosphere, the carbon dioxide is not a gas you breathe, and it is not a liquid you swim in. It is something else entirely. A supercritical fluid that just sits on your skin with a heaviness that feels wrong. The pressure is 92 times what you're used to. That number is just a number until you feel it. It is the weight of the entire sky pressing down on you from every direction at once. It does not push you flat. It just holds you. It squeezes the space out of your lungs before you can even try to use them. It makes the air so dense that you could theoretically float a boat on it if you had a boat that could survive the heat, which you do not. Think about the molecules. They are packed so tightly together that they bump into each other constantly. A frantic, crowded room where no one has enough space to move. This is the microscopic reality of the surface, a chaos of carbon and oxygen, crushed into a state that defies the simple categories we learn in school. It is a fluid, yes, but it expands to fill its container like a gas, and it dissolves things like a solvent. It just goes. It does what it wants, governed by a thermodynamic rulebook that we only half understand. Move outward from the molecules. Look at the space between them. There is almost no space. The mean free path, the distance a molecule can travel before it hits another one, is measured in nanometers. Light cannot travel in a straight line here. It scatters. It bounces. The sky does not look like a sky. It looks like the inside of a fog bank that has been heated to the melting point of lead. The illumination is a flat, shadowless orange glow that comes from everywhere and nowhere, a diffuse radiance that makes it impossible to tell how far away anything is. Move outward again. Look at the column of air above you. 92 bars of pressure means there is a lot of air above you. It is a column of fluid stretching up through the clouds, up through the haze, all the way to the edge of space. The mass of that column is what creates the pressure. The gravity of the planet is pulling down on that mass, and the mass is pushing back, and you are caught in the middle. The weight is absolute. It does not fluctuate. There are no high-pressure systems or low-pressure systems at the surface. No weather fronts moving in to change the barometric reading. The weather is just heavy. It is a permanent, unchanging crush. Move outward to the planet. The entire mass of the atmosphere is about 90 times the mass of Earth's atmosphere. It is a staggering amount of gas wrapped around a rocky core. The surface pressure is not an accident of local geography. It is the global condition. Whether you stand on a basalt plain or at the peak of a volcano, the pressure is roughly the same. The atmosphere is so efficient at distributing heat and mass that the surface is an isobaric nightmare. A place where the concept of a weather map is entirely useless, because the map would just be one solid colour. The bodily experience of this, if you strip away the fatal heat and the toxic chemistry, is one of absolute containment. You are not in an open space, you're in a closed system. The air is holding you so tightly that you cannot move without displacing a fluid that does not want to be displaced. Sound travels differently here. It moves faster because the medium is denser and it carries more energy. A whisper would sound like a shout. A shout would sound like a physical blow. The acoustic environment is as oppressive as the physical one. We measure this pressure with probes that were built to survive for a few hours, knowing they will eventually be crushed or melted or both. The Veneer landers sent back pictures, and in those pictures you can see the haze, you can see the rocks, but you cannot see the weight. You cannot see the 92 bars pressing down on the lens, distorting the light, bending the world into a flat orange smear. The instruments felt it. They registered the crush. And then they stopped working, because the weight of the air is not something that can be ignored for long. The pressure sits there. It is the baseline. It is the floor. It is the condition that makes everything else on the surface secondary. Because before you can ask what the rocks are made of or how the wind moves, you have to acknowledge that the air itself is a solid thing. A heavy, crushing, supercritical blanket that has smothered the ground for billions of years, holding it in place, keeping it quiet, keeping it still, pressing down with a patience that makes the concept of resistance feel like a joke, a weight so total and so complete that the ground itself has learned to just accept it, to bear it, to exist underneath it without ever once trying to push it back. The missing shield. Far away at the centre of the system, the sun is constantly throwing pieces of itself outward in a stream of charged particles that we call the solar wind, a relentless, invisible gale that moves at hundreds of kilometers per second, carrying with it the sun's magnetic field and a quiet, persistent violence that strips away anything that does not know how to defend itself. And this wind has been blowing for 4.5 billion years, shaping the space between the planets, carving away the atmospheres of worlds that could not hold them, and it hits Venus with a force that should have emptied the sky a long time ago. Earth has a shield. Deep inside the planet, in the liquid outer core, the movement of molten iron generates a magnetic field, a vast invisible bubble that extends tens of thousands of kilometers into space, deflecting the solar wind, parting it like a river around a stone, protecting the atmosphere from being eroded away by the star's breath. We take this shield for granted. We assume that a planet of Earth's size and composition will naturally have one, that the dynamo in the core is just a standard feature of a rocky world, a built-in defense mechanism that comes with the package. Venus does not have this. The dynamo inside Venus is either dead or never fully formed, and as a result, the planet has no intrinsic magnetic field, no global bubble to push the solar wind aside, leaving the upper atmosphere completely exposed to the full, unfiltered impact of the star's outflow. When the solar wind reaches Venus, it does not part. It hits the ionosphere, the layer of charged particles at the top of the atmosphere, directly, compressing it on the day side and dragging it out into a long, sprawling tail on the night side. The interaction creates what scientists call an induced magnetosphere, a fake shield, a temporary localized magnetic barrier generated by the electrical currents in the ionosphere itself, reacting to the pressure of the solar wind. It is a shield made of the very thing it is trying to protect. It is the atmosphere defending itself by becoming magnetic, by generating just enough field to slow the solar wind down, to create a bow shock upstream of the planet, to absorb the worst of the impact. But it is not enough to stop the erosion. The solar wind still gets in, it still interacts with the ions in the upper atmosphere, and it still carries them away. The spatial reality of this is a slow, continuous bleeding. On the day side, the solar wind compresses the ionosphere, pushing it down, squeezing the protective layer closest to the surface. On the night side, the wind drags the ionospheric plasma out into a long magnetic tail that stretches millions of kilometers into space, a river of stolen atmosphere flowing away from the planet, carried off by the star's breath. Ions of oxygen, hydrogen, and heavier elements are picked up by the solar wind and accelerated away, lost to the void, never to return. This process has been happening for billions of years, and it is the reason Venus has no water, the reason its early oceans boiled away and were then stripped from the sky, leaving behind only the heavy, dry carbon dioxide that makes up the rest of the air. The orbit of this loss is not a single event, it is a cycle. The sun rotates, the solar wind changes. Sometimes it is fast, sometimes it is slow, sometimes it carries a strong magnetic field, sometimes it does not. Venus moves through this changing environment, and the induced magnetosphere shifts and flexes in response, a dynamic, unstable boundary that is constantly being pushed and pulled, constantly losing a little bit of itself to the dark. There is no moment of crisis. There is no dramatic stripping of the atmosphere in a single cinematic event. It is just a quiet, persistent leak, a slow exhalation that has been going on since the planet was young, a gradual thinning of the lighter elements until only the heaviest, most stubborn gases were left behind. We measure this loss with spacecraft that fly through the tail, counting the ions, measuring the flow, trying to calculate the total mass that escapes every second. The numbers are small on a human scale, but on a geological scale, they are devastating. Over billions of years, the loss of water and hydrogen has fundamentally altered the chemistry of the planet, locking the oxygen into the crust, leaving the carbon to dominate the sky. The missing shield did not just fail to protect the atmosphere, it actively participated in changing it, allowing the sun to rewrite the composition of the air to take a world that might have been blue and green and turn it into the yellow, crushing hellscape we see today. The wind blows, the ions drift. The tail stretches out behind the planet, a long invisible scar in the solar wind marking the path of a world that is slowly, quietly, inevitably losing itself to the star it orbits, a process that we can only understand by looking at the space around it, by measuring the empty places where the atmosphere used to be, by tracing the shape of the missing shield, and realizing that the shield was never really there at all, just a temporary arrangement of charged particles doing their best to hold back a tide that they were never going to be able to stop. The continents of glass. The ground is moving. Not the slow turn of the planet, but the rock itself, shifting and folding and breaking under the weight of the mantle below, pushing up into the sky in massive deformed blocks of crust that we call tesserae, the oldest and most rugged terrain on the planet, places where the surface has been compressed and stretched and crumpled so many times that it looks like a frozen ocean of stone. A chaotic, fractured landscape that tells a story of tectonic violence we are only just beginning to read. There are no tectonic plates here, not in the way Earth has them. There is no neat system of conveyor belts carrying crust down into the mantle and pulling new crust up at the ridges. The Venusian crust is too hot, too dry, and too thick to subduct cleanly. Instead, the heat from the interior builds up, pushes against the base of the crust, and eventually forces its way through, creating vast volcanic plains, massive shield volcanoes, and these strange, highly deformed highlands that rise up above the plains like continents, standing a few kilometers higher than the surrounding rock, buoyed by the thick, hot crust beneath them. Ishtar Terra is one of these highlands. It is roughly the size of Australia, sitting near the north pole of the planet, a massive elevated region of crushed and folded terrain. At its western edge it runs into the Maxwell Montes, a mountain range that rises even higher, pushing up into the atmosphere, the highest point on their planet. The rocks here are older than the surrounding plains. They have survived the volcanic resurfacing events that wiped the rest of the surface clean, sitting above the lava flows, untouched, preserving a record of the planet's early history that is otherwise completely lost. The radar images of these highlands are strange. They are incredibly bright. The radar signals bounce back with an intensity that normal basaltic rock cannot produce. At first, people thought it was just the roughness of the terrain, that the steep slopes and fractured rock were reflecting the signal directly back to the spacecraft. But the brightness is too high, too uniform, and it appears at specific altitudes, above a certain elevation threshold, across multiple different highland regions. The leading explanation is metal snow. At the surface temperature of Venus, certain minerals that are solid at lower temperatures become volatile. They sublimate. They turn from solid rock into gas, rising up into the atmosphere carried by the faint surface winds. When they reach the higher elevations where the temperature is just a few degrees cooler, they condense. They fall back to the surface as a frost, a thin layer of solid material coating the rocks. The most likely candidate is galena, lead sulfide, or perhaps bismuthinite, minerals that can sublimate at the temperatures found on the Venusian plains and condense at the cooler temperatures of the highland peaks. The idea of metal snow is difficult to hold in your head. It sounds like science fiction, a poetic flourish added by scientists who are tired of looking at basalt. But the thermodynamics work. The vapor pressure of these minerals at 460 degrees is just high enough to allow them to enter the atmosphere, and the temperature drop at higher elevations is just enough to cause them to precipitate. The highlands of Venus are coated in a thin reflective layer of condensed metal, a frost that sparkles in the radar beams, making the mountains look like they are made of glass or ice, even though the ice would vaporize instantly and the glass would melt. The sediment of this landscape is not made of sand or soil. It is made of this strange metallic frost, layered over ancient deformed crust, sitting on top of a mantle that is slowly, patiently pushing it upward. The tectonic forces that created the tesserae operated on a timescale that makes human history look like a brief interruption, a slow, grinding compression that took hundreds of millions of years to fold the crust into the complex, intersecting patterns we see in the radar data. The rock was squeezed, heated, and broken over and over again until it reached a state of equilibrium that it maintains today, sitting quietly under the heavy atmosphere, waiting for the next time the mantle decides to push. We do not know exactly how the tesserae formed. We do not know if they are the remnants of an early, Earth-like plate tectonic system that failed, or if they are the result of a completely different style of deformation, a global compression event that happened all at once. The models are still being argued over, the simulations still being run, the radar data still being passed for clues. But the physical reality is there, sitting on the surface, a landscape of crushed rock and metal frost that defies the simple categories we use for other worlds, a place where the geology is as heavy and as opaque as the atmosphere above it, keeping its history hidden in the bright, radar-reflective folds of its ancient crust. The mountains sit, the frost coats them, the mantle pushes, the crust folds. It is a slow, continuous process of deformation and condensation, a landscape that is constantly being rebuilt by the heat from below and the chemistry from above, a place where the rock itself has learned to change its state, to sublimate and condense, to move through the atmosphere in a cycle that has nothing to do with water and everything to do with the strange, heavy, metallic reality of a world that refuses to behave the way we expect it to. The shadow in the clouds. The argument has already started, and it is not going to stop anytime soon, because the thing that started it is a single, faint absorption line in a spectrum of light that came from the clouds, a tiny dip in the radio signal that could mean almost nothing, or it could mean everything, depending on who you ask and what day of the week it is, and how much they want to believe that life can exist in a place that is actively trying to destroy it. The clouds of Venus are not just a blanket of sulfuric acid. They are a complex layered structure, a vertical world with its own zones and temperatures and chemistries, and about 50 to 60 kilometers above the surface, the conditions change. The crushing pressure of the surface drops away, down to roughly 1 or 2 bars, almost the same as the pressure at sea level on Earth. The lethal heat drops away too, cooling down to a range of 0 to 60 degrees Celsius, a temperature that is perfectly comfortable for liquid water, perfectly comfortable for complex chemistry, perfectly comfortable for the kind of biological processes that we associate with life. It is a temperate zone, a narrow band in the sky where the hellish conditions of the surface and the freezing vacuum of space meet and cancel each other out, creating a region that is, by the standards of the rest of the planet, almost benign. And it is in this zone that the droplets of sulfuric acid hang, suspended in the updrafts and downdrafts of the super-rotating atmosphere. Tiny acidic spheres that are constantly being rained down into the hotter layers below, where they evaporate, and constantly being carried back up into the cooler layers above, where they condense. A continuous global cycle of droplet formation and destruction that keeps the cloud deck thick and opaque. The thread of this thought leads to a molecule, phosphine. On Earth, phosphine is a gas produced by anaerobic bacteria, by things that live in swamps and in the guts of animals, by biological processes that do not require oxygen. It is not a molecule that forms easily in an oxidizing atmosphere. It is destroyed quickly by the chemistry of the air. If you find it in the atmosphere of a rocky planet, you have to explain where it came from, because the universe does not just make it and leave it sitting there. A few years ago, a team of astronomers looked at the spectrum of Venus, using 2 different telescopes, looking for things that no one expected to find, and they saw a dip in the signal at a very specific wavelength, a frequency that corresponds to phosphine. The signal was faint. It was barely above the noise, but it was there, and it was in the temperate zone of the clouds, and it could not be easily explained by any known abiotic chemistry. The volcanoes were not hot enough to produce it. The lightning was not frequent enough. The photochemistry of the atmosphere should have destroyed it faster than it could be made. The aftermath of that announcement was a storm of papers, of rebuttals, of reanalyses, of scientists arguing over the calibration of the telescopes and the subtraction of the background noise and the exact shape of the absorption line. Some said the signal was an artifact, a mistake in the data processing, a ghost in the machine. Others said it was real, but that there was some unknown chemistry in the clouds that could produce it without biology, and a few, quietly, carefully, said that if it was real, and if it wasn't chemistry, then it might be life, microbes floating in the temperate zone, riding the droplets, surviving the acid, reproducing in the only place on the planet where the conditions allow it. I am uncertain. The data is messy. The arguments are technical and dense and often contradictory. The idea of life in the clouds of Venus is so striking, so poetic, so perfectly aligned with our desire to find life everywhere, that it is hard to look at it without wanting it to be true. But the universe is not obligated to give us what we want, and the evidence for phosphine is still contested, still debated, still hanging by a thread of statistical significance that could snap the next time someone runs the data through a different algorithm. But the thread remains. It leads up into the clouds, into the droplets, into the temperate zone where the pressure is right, and the temperature is right, and the only thing missing is a reason for life to exist in a sea of sulfuric acid. And as long as the thread is there, as long as the signal is not completely ruled out, the possibility remains. A quiet, persistent shadow in the data, a reminder that even on a world that is as hostile as we can imagine, there might still be a place where something could survive, where the chemistry could cross the line into biology, where the clouds could be hiding a secret that we are only just beginning to suspect. The clouds move, the droplets fall. The signal sits in the data, faint and unresolved, waiting for the next telescope, the next observation, the next paper to either confirm it or erase it. A tiny, invisible ghost in the atmosphere of a world that has already given us so many reasons to be surprised, holding on to one last fragile possibility that we are not alone, even here, even now, even in the acid and the heat and the dark.